What would happen if that goes in there? What would those numbers turn out to be? We're going to come in from the other side now. We're going to see if we get a different answer or not. What is the limit as x approaches 3 from the right-hand side of 2 plus x over 3 minus x? And Brian's up. Take your time. You need to write it down? Okay. So just tell me what's happening on top and bottom.
So you're approaching 3 from the right.
3 from the right.
And then at the top.
So where's the top headed? 5 over 0. Okay, so we're back in this scenario, right? So we look at our little sheet, right? We look at our little cheat sheet, and we say to ourselves, all right, we are looking at the bottom left. My intention is to, and I apologize for this, my intention is to not allow this on the test. All right? This is here for you to learn from. But you should at some point become comfortable with the idea that when I have a fixed number over 0, I know that my answer is either going to be infinity or negative infinity or does not exist. Like something, one of those has to happen. All right, so let's try this. Brian, I'm going to stick with you. I'm going to draw a number line, okay? I'm going to put 3 here. Which side are we approaching it from, left or right? Right side. Okay, so Brian, give me an example of a number that would be going into that limit as I started to get close to 3. Okay, which side of 3 are you on, though? See, here's 4, right? And here's 2. So 3.1, 3.01. No, it's okay. This is where I want you to think through it, right? So 3.0. Let's go 3.001. Let's go to that one. That's pretty close to 3, right? Okay. So Brian, if I plug that number into here, then 3 take away 3.001. Is that answer going to be positive or negative?
What'd you say? I'm sorry.
Okay, so I'm taking the number 3, right? And I'm taking a number that's close to 3, but coming in from the right. So something like this. If I plug that in there, 3 take away that, is that answer positive or negative? It's negative, right? Which means my denominator is approaching 0, but it's going to be negative the whole time because I'm coming in from this side. Now the numerator is 5, and 5 is positive. There's no changing that, right? So now what you have is a number that's fixed on top, right? A number on the bottom that's headed to 0. We know that becomes infinite, but the top is positive and the bottom is negative. And the ratio of a positive and negative number must be negative. So this heads to negative infinity, and that's what your table shows you. So the answer here is negative infinity. Do y'all see that? Understand that? Yes?
Let's say it's approaching from the.
Here's what I'm saying. Here's 3. Do y'all see my graph here? Here's, I graph this function. We know that at 3 it's undefined, right? At 3 it's undefined. But this question was asking what happens as you approach 3 from the left. Without looking at a graph, we were able to determine that that would be like plugging in 2.9 or 2.999, and that would give us a positive number over something going to 0, but they would both be positive, and therefore we would head to infinity. And sure enough, you can see that from the left, we are headed towards positive infinity. Now, if we approach 3 from the right-hand side, we're plugging in numbers that are a little bit bigger than 3, and therefore when we plug them in, we get a little tiny negative number down here. And the ratio of a positive and negative is negative, so that means it's got to be headed to negative infinity. Is that answering anything?
Technically, it's like negative 0.001, right?
Once you plug it in here. Once you plug it in there. And then if you take 5, positive 5, and divide it by negative 0.0001 or whatever, you're going to get a big number, right? Okay, yes?
Can't you just say, like, the limit is like a negative, it'll be positive on the sheet?
You mean like if this is negative, then your answer there is going to be positive? And
Yeah.
what do you think?
Yeah.
You think so?
I mean,
If that's the way it was, I would have just taught it that way.
yeah.
Okay? Anytime that there's something that always holds, I would just teach it that way. But unfortunately, you have to inspect. Let's do an example that would be counterintuitive, that would go against that. All right? So let me make one up real quick. We're going to do a new problem. Oh, by the way, 1.6, this section, we're supposed to take 2 days on. All right, so we're only going to be getting through half of this today. All right, let's do the limit. Let's go x approaches -4 of the function x squared plus, let's go negative x squared plus 1 over 4 plus x. I don't know, I mean, you're sitting there, right? Is this starting to feel a little bit more like I guess what in your mind calculus is supposed to be a little bit more thinking? Is it feeling that way a little bit? Okay. Derek, where's Derek at? Derek, how's it going, man? First thing we always do, Derek, plug in, right? So this is, just be careful with that negative sign there. What do you get there, Derek, when you plug -4 in? Pardon? 17, is it 17? Got to be kind of careful here. This negative sign, you ignore it until after you've squared. Okay, so -4 goes in there first and gets squared and becomes 16. Then negative, then 1. So -15 on top. Okay, -15 on top. All right, keep going. What about the bottom? Over 0. Okay, so Derek, out of all of the things on here, where are we at? Top left, top right, bottom left, bottom right? We're bottom left, right? So all you have to do now is determine whether or not the top is positive or negative and whether or not the bottom is headed towards 0 through positive or negative numbers. You can already tell me about the top, right? The top is a fixed number and it is negative, right? So we know we've already narrowed it down to 2 possibilities here, right? Okay, now the bottom, we need to determine how we're going to that 0. So I'm going to stick with you, Derek, because you seem to be rolling here. What should I do next? What have I been doing at this point? Okay, so draw a number line, right? Draw a little number line and put here what? What am I going to put on the number line?
0.
Not 0. Where are we headed? We're headed to -4. Which side are we coming in from, Derek?
Both, right?
Ah, so see, I didn't say, right? And since I didn't say, you have to check both ways. Because the only way that this limit exists is what? Is if it's the same from both sides, right? So we have to do 2 separate checks right now. So let me actually let me do this a little different. We know that this is true, right? So what we're going to do first is we're going to do from left. Let's do that right here. From the left means we need to look at the limit as x approaches -4 from the left of -x squared plus 1 over 4 plus x. And Derek, nothing changes here in terms of we still have -15 over 0, right? But it's the way we're approaching -4. So which side am I going to come in from if I'm doing that? Right, left. So over here. So now, Derek, be very careful, Derek. You know what? I think I've picked on you enough. How about Luis? Okay.
-4 point.
Good job. -4.01. Ah, very good. You know what a lot of people say when I put that up there? What a lot of people give me? -3.99. So you have to make sure you understand how the negative numbers lie on the number line, right? Negative 3 is over here. Negative 5 is over here, right? So if you're coming in from the left, you're actually a little bit past negative 4, which means you're at negative 4.101. Good. Everyone see that? How that can be tricky? Okay, so now that's going to get plugged in, right? So you're just going to do like a visual inspection. That goes into here. And when you do that, you get a number that's what? When this goes in, when you take a number to the left of this, plug it in here, you're going to get a number that's negative, right? And that's all that matters to you. Because you know the top is negative. It was just a question of whether or not the bottom was negative or positive. So we plug that in. 4 plus this negative number is a negative number. So we know that that's there. So what's happening then? What is this limit? What is it? Infinity. Because from the it was negative on top and bottom on that table, negative and negative is positive. So now we have to come in from the right. Edward? Okay. So from the right, we're doing the limit. X approaches negative 4 from the right of negative x squared plus 1 over 4 plus x. And when I do that, what do I do now? Number line again. Here, I put what here? Negative 4. And which side am I coming in from? Right side. So from here, give me a number on this side.
3.9.
Okay, so negative 3.99, something like that. Okay, now visually, plug that in here. And remember, we know that this went to negative 15, right? Over 0, we were just trying to determine what the bottom was. So what's it going to be on the bottom now? Positive, right? We know it's going to 0, but it's going to be positive. So this little positive number, because when you plug that in right there, you get a positive number. And so you have a negative over a positive, so that limit should be what? Negative infinity, right? Negative over positive. Now we get to answer the original question. What's the answer, Alberto? Where's Alberto? What's the answer to the original question? This is the original question right here. So which side is it telling you to come in from on the original question? Both sides. And look at the both sides. They're not the same. So this limit does not exist. Yes, the left-hand limit exists, and it goes to infinity. The right-hand limit exists. It goes to negative infinity. But the limit without any indication of left and right does not exist. Yes?
Can you pull that up on a graph?
Yes?
When I graph it, it'll show one thing.
I forgot my parentheses. Over 4 plus x. Right?
Yeah.
And we're interested in what's happening at 4? Is that right? Wait, did I write that?
Negative 4.
Negative 4. Okay, so here's negative 4. Why is this not moving? There we go. I have to zoom out. There it is. I think you're just not zoomed where you can see the other part. But here's negative 4, and then so from the left you're headed to positive infinity. From the right you're headed to negative infinity. Damn, this is fun, right? It's not? Okay. I was hoping if I was all eager like that, you might. No. All right.
You could say that most people in here are at their limit.
You're at that. I can tell, Jace, that you're going to be some comic relief for us in here.
Yeah.
Okay, so how about this? How about this? So Frank's going to get lucky. Where's Frank? Where's Frank? Oh, Frank's not lucky then. Franklin? No? We're going to have to put an extra mark on his then. Michael? Sandoval? All right, you're going to get lucky here, all right? Because I'm not going to ask you a question. I'm going to kind of yell at you a little bit, all right? Do not tell me sign of junk and junk. Don't be thinking that. Why? Why, everyone? Why is Michael not going to be going, oh, this is that sign junk stuff? Why is he not going to do that? Because Michael remembers the first step for taking any limit. And the first step, Michael, is to do what? Plug it. Okay, so what do you get, Michael, when you just plug in? What do you get? 2 over what? 0, right? Okay, and that's not bad. I mean, that's not that bad algebra thing anymore, right? So you don't use sign junk over junk if you've got this happening. You only use sign junk over junk when you have 0 over 0. So this, it falls into one of the 4 little things on the bottom left, okay? Now, 1 is going to help us figure out what the numerator is doing. So the numerator, according to that little sheet I gave you, we said we were in the bottom left. So the top 2 right here can be looked at as being fixed, right? 2 is fixed, and it's fixed what? Positive or negative? Positive, right? So our numerator is fixed and positive. And so all we need to do is figure out what's happening with the bottom, right? Just what's happening with the bottom. And you know what? Just for the sake of time, okay, for the sake of time, let's come in from the left-hand side, and let's just do that one. If I left that little negative off right there, we'd have to come in from both sides, wouldn't we? Now this is going to be a little different than the last problem. Jace, you're up. Jace, in the last problem, what I did was I did a number line, right? And I put the number 0. Like in this case, we put 0. I'm going to do that again, all right? Okay, and which side are we approaching that from, Jace? From the left, right? So I'm going to do that. And now I'm plugging that number. Give me a number here, Jace. Negative? Negative 0.1? That good? Everyone good with that? But I'm supposed to plug that in, right? Plug that in where? To sine function. See, that's different than what we've done before, right? Before we had 4 plus x, so when we plugged in the number, it was real easy to, well, I hope it was easy to just look at it and know if it was positive or negative. But here, if I say negative 0.1, plug it into sine, well, you're either going to break your calculator out, right? Or you're going to go back from what you learned in pre-cal, and you're just going to do a quick mental graph of the sine function. Here's the sine function, right? And it extends the other way, doesn't it? Yep. And we're approaching, it's like we're trying to plug 0 into that, but we're coming in from the left. So on the sine function, if we come in from the left, here's 0. If we come in from the left, aren't we down here? Coming in like that? And aren't those little values in here negative? Because they're below the x-axis. So that means we are, when you plug that number in, sine of that is giving you a negative number. And therefore we're approaching through negatives there. And that means the answer is what? Negative infinity. Now, if you just get on your calculator and do sine of negative 0.1, you got to make sure you're in radian mode, and it'll spit out a negative answer. And that's all you care about is whether or not it's positive or negative. That's all you care about.
So you don't care about the long decimal number?
We don't care. We don't care. We know, and this is one thing you're going to take away from this, probably going to be out with your friends this weekend at the Super Bowl party. You'd be like, you know what? But fixed number over 0 always goes to infinity or negative infinity. That's what you're going to be talking about, right? That's like the big takeaway. So we don't care about the numbers. We care about the signs. Is it positive over negative, or is it positive over positive, or is it negative over positive, or negative over negative? That's all we're concerned about. All right. Just curious, if I change this problem slightly, if I take that out, that means we'd have to come in from both sides, right? And what if I put sine squared instead? How would that change things? Would the top still go to 2? Would the bottom still go to 0? Well, when you plug 0 in here, sine of 0 is what? Remember, that means sine x squared. So you first plug 0 in. Sine of 0 is 0. And then you square that, you have 0. So the bottom is headed towards 0, right? So we have fixed on top. 2 is positive. Now the bottom. Do we have to actually do any work? We know the bottom's headed towards 0, don't we? And we've been saying, oh, but we got to figure out if it's positive or negative. Can you tell me without doing any work whether or not it's positive or negative? Why is it positive? Because it's squared. Look, we know this is headed to 0. That's headed towards 0. That might be having little tiny negative numbers or positive numbers. That's going to 0. But who cares? We're squaring it. And when you square it, it's positive. And therefore, we can tell just by looking at this that that's positive. And therefore, this goes to positive infinity. From both sides. From both sides. Because the squaring makes that happen. Now, what if I change that to cube? Well, now you have to check, right? Fourth power, you're done. Straight to that. Do y'all see how that would have worked? All right. Let me take a look at something. Everyone's saying I sound sick. I know I sound sick. I feel great. Let's see here. Yeah, this one will be interesting. Limit x approaches pi over 2 from the right-hand side of tangent of x. Nas, you're up again.
Sure. We plug in pi over 2 first.
Okay.
Right? And then pi over 2.
So we need to know what tangent of pi over 2 is.
It's
So
0
it,
over 1.
yeah, it might help us if we just first rewrite this. How about we go tangent is sine over cosine, right? So Nas, sine of pi over 2 is 1, and cosine of pi over 2 is 0. So what's happening here is we're getting 1 over 0 when we take that limit. And that's fixed over 0. So now we've fallen into that bottom left corner of the table that I gave you. What can you tell me about the top, Nas? It's fixed, right?
Yes.
But it's fixed what? I'm only concerned about positive and negative, right? So the top is fixed, positive, right? Now we have to go about trying to find out what's happening with the denominator. We know it's headed to 0, but is it positive or negative?
We need to check.
We need to check, right? So do what we've done before. Let's draw a number line. Let's put pi over 2 here. Which side are we coming in from? Sorry, I'm asking you and then I'm already doing it. Sorry about that.
Right. Yeah.
So then you'd have to pick a number over there, wouldn't you?
Yes. It's
I mean, you could do something, right? Like you could find a number, but here's where I think it's so much better to just kind of not do that and think about the piece you're looking at. Nas, you know what that looks like, right? That's the part that's going to 0. Okay, could we graph that quickly? Can we graph a cosine function? That's cosine. This stops at 2 pi. That's pi halfway is pi, right? And then half of that is pi over 2, right? So to say we're approaching from the right pi over 2 and then going into cosine means we're on this graph approaching pi over 2 from the right. So where's that? It's approaching 0, but through positives or negatives. Positives or negatives.
It's positive, right?
Which side are we approaching pi over 2 from?
From the right.
From the right. So on this graph,
Yes.
If we're on the cosine function, we're approaching pi over 2 from the right.
Yes.
We're coming in like this, aren't we?
Yes.
And when we're here, the value of cosine, we know the value of that function, that's this one, is approaching 0. But these little guys are below the x-axis, aren't they? So they're negative numbers,
Yes.
aren't they?
No, no.
So since these are all negative numbers, that means that those are little negative numbers as they go in. Does that all make sense? Now, if you don't like this, well, then you could just try and pick a number a little bit bigger than pi over 2. Go ahead and figure out how to do that.
Plug it in.
And then plug that into cosine, and then you'll see it's negative. I think this is much more constructive, though, because I'm not using any calculator and I'm figuring it all out. I just have to know what these graphs look like. So what if I would have approached, oh, what's the answer? Sorry, what's the answer? Negative infinity. Positive over negative. So would the answer have changed if I approached from the left? Absolutely, because even though we still get 1 over 0, we get fixed positive. If we approach from the left, now we're on this side of the cosine function, because we're approaching pi over 2 from this side. So we are positive little numbers. These are all above the x-axis. Positive, positive, positive. So that would be positive, and the answer would be positive infinity. All right. Man, this is fun. I'm just the messenger, okay? I'm just the messenger. You know, we've been talking about, you know, drawing a number line and then getting a number closer and closer and closer. And people have been telling me like this would be like 0.9, and then you get closer, you know, 0.99, and then 0.999, right? And you get closer and closer. So I just have a question for you. Is there a number, like a closest number to 1? Like, is there a number that is the closest number possibly to 1? You're already saying no. You don't think so? Why not?
The number to 1 is infinitely.
So you think there's like an infinite number of numbers next to 1, and that there's no number right next to it? Okay. Do you all buy that, or have you ever thought about it? Probably not, right? Okay, so let's say I wanted to argue with you, or someone in the class wanted to argue with you and challenge that idea that you're saying there is no number that is right next to 1. So somebody else in the class, challenge her with a number that you would think would be the one right next to it. Does anyone have an idea of what number they think could be right next to 1? These are getting closer, right?
That's infinity.
Like 1?
That's closer. I'm getting closer and closer, right?
One more.
All of those numbers get closer and closer to 1, don't they? How about this number? 0.9 repeating. I'm pretty damn close to your 1, don't you think? Do you think you could find anything closer than that?
1 over infinity.
I'm just saying this is the number 1, right? I'm claiming that I think that number is as close to 1 as you could ever get. Nobody is ever going to find a number closer than that. Yeah?
There's another one. 1.1.
Oh, on the other side. Sorry, the other side also. Yes, we could. Yeah, let's just say on this side. Yeah, we'll ignore the other side for now.
Okay.
Okay?
Not just being heard.
No, that's good, that's good. So this is a pretty good candidate, isn't it? I like this guy. He looks like, he looks like he's the closest one-to-one. Yes? You still don't buy it? You still think there's another one? Something closer? All right, here we go. I'm about to follow through some algebra. And I just want you to tell me whether or not you're good with it or not. Like, yes, I can do that. No, I can't. All right, so here we go. Let x be 0.999, repeated. That number, right? That's that number. I'm going to call it x. Everyone okay with that if I call that x? Anyone have any problems with that? That's x. All right. Let me ask you this. What is 10x then? So when we multiply a decimal by 10, what happens to the decimal point? Moves over, doesn't it? Okay. So do you agree with me right now that 10 times x, if I'm calling that x, then 10 times x would be 9.99, and I still have a bunch of 9s going forever, right? So that's the same, right? Okay. Now, let me ask you this question. Ignore all of this for a moment, and let me just ask you this. What's 10x minus x back in a college algebra class? That's 9x, isn't it? But if 10x is 9.99 forever, and x is 0.99 forever, right? That's x. If I subtract them, then what should I get? Over here, what should I get? 9. Why? Why? All these 0.9s that go out forever get killed off, if I subtract this, get killed off by all those 0.9s forever, don't they? Yes? And so all you're left with here is what? 9. But these two have to be the same, right? These are the same. Which means that what? If 9x is equal to 9, then that means x is what? 1. So what am I saying to you right now? I said, hey everyone, x is 0.999 forever. Then I did basic algebra and came to the conclusion that x is what? 1. Which means this is 1. So that is not the number closest to 1. That is the number 1. Are you okay with that? 0.99 forever is 1. You don't like it. That's why I showed it to you. 0.99, the repeating decimal forever, is 1. There is no number between these. They are the same number.
So is 0.8 repeating 0.9?
No, 0.8 repeating would not be 0.9. 0.8 repeating, right? 0.8 repeating would not be 0.9 because I could get closer. I could do 0.891 would be closer than that, right? But how about 0.8999 repeating? That right there. Yeah, that right there would be 0.9. Okay, so we're going off a little bit on a tangent, but when we're doing this and we're approaching from one side and we're picking a number, you could not pick, like if you're trying to approach 1, it would not be, like mathematically, it would not be okay to pick 0.9 repeated, because then you're picking 1. This usually bothers people, and I understand why it would. All right, this is a very, very troubling idea. All right, so we are out of time. I knew we were out of time. I didn't want to start the new section, but I have to pass around this little sign-in sheet. Also, I will pass around office hour, or the bonus. I've already had some people no show, no call. Well, I don't know. So I'm there, I'm all excited. I'm sitting there like all looking out the window, waiting, and and then nobody shows up, and I'm all depressed, and I need a I need a safe space to go crawl into. Oh, you didn't get a sheet? Anyone else not get a formula sheet? The limit sheet? You didn't get one? I'm sorry, you should have told me. So on your homework for, I'll get you in a second. For your homework on 1-6, y'all listening? For the homework on 1-6, don't do anything past number 18. Because everything else is stuff we haven't done. So you can only do problems up through number 18. How are y'all feeling about all this? Come on, I'll turn off the camera and y'all can be honest.